Did you miss me? Still got the shiny head. And just in case you're wondering, I'm drinking my Dunkin' Donuts coffee. Nobody actually cares. My God, that wind, man. I hope my house doesn't fall down. This is cray cray. By the way, my name is Mr. Kraus. You can call me Mr. Key for the next hour. By the way, I know I never say this, but probably should. All this stuff can be found at www.mrkrausmath.com. You go here, you click on Algebra 2. We're on Unit 7. You go here. Right now I got day 1, day 0, and day 1 up. Not day 2. Just finished that. And we're doing day 3. It'll be up soon. But the documents are here. If you want the entire thing, just click on here for the entire unit, and they're all yours. And you can learn about trigonometry for the Algebra 2 Common Core test. So we don't need that. Let's get rid of that. Let's talk about this. Day 3 notes. Day 3. Okay, if you haven't taken the time to do this real quick. Pause the video. Go ahead, pause it. Pause it. Pause it. I'm going to pause mine too, so you can't make me do this. Pause. I'll be right back. I'm back. There they are. Hopefully you got them right. Some old hippie caught another hippie tripping on alligators, and all these are the reciprocal functions. Flip them upside down, kiddos. All right, I'm going to pause it again. You complete the reference triangle, the 30, 60, 90 triangle. I'll help you out. This is the 30-degree angle. This is the 60-degree angle. These are 45s. All right, I'm going to pause it. All right, I'm back. You should have these down. If not, pause it now and copy them. Oh, you copycat. You should have had them down. Remember, 30, 60, 90 triangle. The hypotenuse is always going to be 2. In our two reference triangles, the hypotenuses will always be 2. That side's opposite the 30-degree angle is 1. Opposite the 60 is the square root of 3. And then these two sides are always the square root of 3. So let's talk about quadrants. Given the following values, sine of cosine of theta, determine which quadrant it lies. Okay, so remember yesterday we talked about all students take calculus. This is how I go about it. Again, the only thing I care about is the signs, positive or negative. All right, so if I look at this, you see negative 1/4. I see negative. Now, if I want sine to be negative, sine is positive here. Everything's positive here. So where is sine negative? Sine is negative here and here. This says cosine is negative. Well, cosine, everything's positive here, and cosine's positive here. So where's cosine negative? Cosine is negative here and negative here. You see how you have two check marks here? Quadrant 2 is the big winner. Let's do that again. I don't know what that is. All students take calculus. So, where is sine positive? Sine is positive here. Sine is positive here. Where is cosine negative? Cosine is negative here. Cosine is negative here. Because everything's positive here and cosine's positive here. So the big winner? Quadrant. I say quadrant 2 over here. This should be quadrant 3. Let's do this real black. In big, bold, and black. Quadrant 2, quadrant 3. This is quadrant 3. This is quadrant 4. Did y'all pick up my mistake? This is quadrant 1, 2, 3. This one here is quadrant 2. All right. All right, you try. I'm going to pause it. You try. I'm going to pause it. There you go. That's my hint for you. Oh. Okay, I'm back. So, what'd you get? Did you get quadrant 1? Both positive. If both are positive, that's quadrant 1. Did you get the right stars? I hope so. So that's not too bad. Now we're going to find this. Okay, so here's what we're going to do on these. We're going to find the other 6 trig functions. The first thing we have to do is figure out what triangle we're going to draw and what quadrant we're going to be in. And we're going to use the information that they give us to do that. So this says we're in quadrant 2. Now, if you remember correctly, we're going to draw the bow tie. We're going to draw the bow tie. So one of I can't erase that for some reason. All right, so one of these triangles, either this one, or this one, or this one, or this one. So let's see. It tells us, oh, we're in quadrant 2. So quadrant 2 means we don't need these. We're only working with this triangle right here. Remember, the angle we choose, in this case theta, will always be the angle made with the x-axis. Don't make a mistake and make... So that's why I always try to draw the bow tie, because that way you always like, oh yeah, I got to pick the one that goes with the x-axis. All right. Opposite over hypotenuse. So this is my hypotenuse, 2. My opposite, the square root of 2. Now, you should have no problem realizing, oh yeah, that's square root of 2, 2. 2, 2. Wait a second, we're in the second quadrant, so that makes this negative. Remember, if we're going in this direction, it's negative. This direction is positive. So sine of theta is the square root of 2 over 2. The cosine of theta is, oh, I should label this, right? Hypotenuse, opposite, adjacent. Cosine. Oh, and I also probably want to write some old hippie caught another hippie tripping on alligators. That'd be kind of funny to watch. So cosine is adjacent over hypotenuse. So adjacent is the square root of 2 over 2, but it's negative. And then tangent theta is opposite over opposite over adjacent, opposite the square root of 2 over negative square root of 2. So square root of 2 over negative square root of 2. But isn't that just negative 1? Now let's do the reciprocal functions. The reciprocal functions are really pretty simple. Do you know what the reciprocal function of sine is? Remember, we hate students, so it's cosecant. C goes with S when we're talking about reciprocal functions. Don't forget that. So reciprocate that. 2 over the square root of 2. You remember what that is rationalized? Hopefully you remember it's just the square root of 2. But if you don't, we're going to multiply by the square root of 2 over the square root of 2. So we get 2 square roots of 2 over square root of 2 times square root of 2 is 2. 2's canceled, and I get square root of 2. Now, having said that, then, ooh, man, so sensitive. What is the reciprocal function of cosine? It is secant. Secant of theta. So that's negative square root of 2, right? We're just going to take the reciprocal of this, but isn't the reciprocal of this the same as the reciprocal of this? Just negative. And then the reciprocal of cotangent is cotangent, so cotangent, and the reciprocal of negative 1 is, you guessed it, negative 1. All right, let's do a little bit more tricky. Now we're going to be a little bit trickier. Now it's not giving us one that's nice, it's giving us one that's not so nice. Now, it is telling us that we are in quadrant 4. And cosine isn't all students take calculus. Cosine is positive here. Cosine is adjacent over hypotenuse. So the adjacent side is 1 and the hypotenuse side is 4. I just don't know this side, and it's not one of the ones I'm really familiar with. So I'm going to have to do the Pythagorean theorem to find it. X squared plus 1 squared equals 4 squared. That's x squared plus 1 equals 16. X squared equals 15. And x equals the square root of 15. Now, be careful. Remember, it's plus or minus, right? We have to decide what it's going to be. The negative is just direction. And if I'm in this quadrant and I'm going down, isn't that going to be negative square root of 15? All right, let's label this sucker. Hypotenuse, adjacent, opposite. All right, let's go through these. Sine of theta. Now, I already know cosine of theta, so I'm going to write that down. That's 1/4. And I know its reciprocal function is secant of theta, and that's just 4 over 1, or just 4. Sine's not bad. It's a opposite over hypotenuse. That's negative square root of 15 over 4. Now, the reciprocal function of secant is cosecant of theta, which is going to be 4 over negative square root of 15. Now, I really shouldn't put this negative down here. I'm just going to leave that negative up here. But I still got to get rid of that square root of 15, so I'm going to multiply by the square root of 15 over the square root of 15. You are going to get really good at rationalizing. So I get negative 4 square roots of 15 over 15. And that's that answer. And yes, it looks kind of cray-cray. And finally, tangent. Tangent of theta is opposite over adjacent, which is negative square root of 15 over 1, or just negative square root of 15. Its reciprocal function is cotangent, and the cotangent of theta would be negative 1 over radical 15. Multiplying by radical 15 over radical 15, I get negative radical 15 over 15. And yes, that's the answer. Great penmanship, Krauss-Lorley. All right, what are we going to do now? Holy crap, everybody freaks out about these. And we want to evaluate the 6 trig functions on this one. But I haven't given you anything other than a point. Wow, that's really tricky. All right, let's plot this point, 8, negative 15. 8, this is our x value. This is our y value. So 8 goes about here. And then negative 15 is down somewhere around here. So that's the point 8, negative 15. Now, nothing's changed. Make a reference triangle with the x-axis. Remember, it's got to be one of these triangles. We want this one. It's got to be one of those 4. So, I'm going to make a reference triangle in the 4th quadrant. So this side is 8, right? Because isn't that how long I counted to get here? And down, I went down 15, so that's negative 15. So I got to find the missing side. So 8 squared plus negative 15 squared equals x squared. So 64 plus 225 equals x squared. X squared equals 289. X is equal to 17. 8, 15, 17 is another one of those Pythagorean triples that almost everybody knows. So 17. And now we're ready to rock and roll. Maybe I'll write some old hippie caught another hippie tripping on alligator. So, I got to label this sucker. If this is my angle, remember my angle is the one that's always made with the x-axis. This is opposite, this is adjacent, and this is hypotenuse. So sine of theta, cosine of theta, tangent of theta. This is how I like to write them. I like to write them like this, and I like to put them right next to each other. Cosecant of theta, secant of theta, and cotangent of theta. So these are the reciprocals, and these are the original functions. So what I want you to do now, I want you to pause the video, pause it, and I want you to come back and see if you get these right. I'm going to pause it, I'm going to put them on there, and then I'll come back in a second and see if you got them right. So pause it. Hit the pause button. Don't cheat because I'm going to fly through this. Okay, how'd you do? Do you have the right ones that are negative? Do you have that the only ones that are going to be positive are cosine? Again, if you use the signs in the triangle, you shouldn't have an issue with this. And if you go back to the idea that all students take calculus, the only thing that should be positive is cosine. All right. Let's try another one. We got to erase. So, let's get going. Negative 7, negative 2. Negative 7, negative 7. Down 2, negative 2. And there's my triangle. Remember, the triangle has to be made with the x-axis, and there's theta. All right, 2 squared plus 7 squared equals x squared equals 4 plus 49, x squared equals 53. Crap, x equals the square root of 53. Not an easy one. All right. So pause the video real quick, and when you come back, make sure you have all of the 6 trig functions, the originals here, and the reciprocal functions here. How'd you do? I hope okay. All right, let's do these. Some old hippie caught another hippie tripping on hippos. Hippos and hippies. All right. Oh, I didn't label my diagram. Let's go. This is my hypotenuse. This is O, and this is A. All right. So sine is opposite over hypotenuse, so that's -2 over the square root of 53. Crap. Got to multiply by the square root of 53 over the square root of 53. The good thing is 53 is prime, so we're not going to really do much with it. So it's equal to -2 square roots of 53 over 53. This one is going to be -7 over the square root of 53. And I think by now you should realize that's going to be -7 square roots of 53 over 53. And then sine is -2 opposite over adjacent -7, or just 2 sevens. Now we take the reciprocals. Now, I'm not going to take the reciprocal of these two because that would be kind of dumb. I'm actually going to take the reciprocal of this for this one. So in this particular case, I get the square root of 53 over -2. We'll put the negative in the numerator. Or the square root of 53 over -7, but we'll put the negative in the numerator. Do you see how taking the reciprocals of the originals was a little bit easier? And then this is just 7 over 2. What do you think? Not too bad, right? All right, let's see what else we got. All right, so we're going to draw a triangle in the quadrant for each scenario. Be sure to label it side with the right signs and check your answers. All right, so first things first, we got to figure out what quadrant we're in. So all students take calculus. We're going to have either this triangle or this triangle or this triangle or this triangle. We got to use one of those 4 triangles, one of those 4. Okay, kids? So sine is negative. Okay, sine is negative down here and down here. So I already know I'm not using those 2 triangles. God bless it. I already know I'm not using those 2 triangles. Cosine is positive. Cosine is positive up here and down there. So now we know who the big winner is. Now remember, cosine is adjacent over hypotenuse. This is opposite over hypotenuse. So we know the hypotenuse is 4. Now, if this is theta, remember this is opposite and this is adjacent. So opposite is negative square root of 7. And cosine is 3 over 4. Adjacent over hypotenuse. So I just want to know tangent of theta. Well, tangent of theta is opposite, which is negative square root of 7 over 3. There's my answer. Oh, this is kind of nice. They told us we're in the second quadrant. So I know I'm going to be using one of these 4 triangles, and since they told us the second quadrant, we're going to go right there. So let's put a theta there. Now, cotangent. So tangent is taking oats away. So this is adjacent over opposite. So if I label this sucker, here's opposite, here's adjacent, here's hypotenuse. Adjacent, -3 over 2. So adjacent over opposite. I still have to find hypotenuse. So 2 squared plus 3 squared equals x squared. X squared equals 13. X is equal to the square root of 13. So the question says, what is cosine of x? So cosine I should say theta. I use x. Let's call theta. Cosine of theta is equal to adjacent over hypotenuse, negative 3 over the square root of 13. But you know you can't leave that. So we have to multiply by. Are you getting good at multiplying by? Do you know it's negative square root of 13 over 13? Negative 3 square root of 13 over 13? Probably getting good at this by now. Negative 3 square root of 13 over 13. All right, what do we got left? 2 left, right? 2 left or 3 left? Oh, 4 left. Crazy. 4 left. Ooh, so quadrant 2. We know we're in quadrant 2. So I'm just going to draw that triangle in quadrant 2. If you're having a hard time realizing, then draw the bow tie and then realize, oh yeah, I'm in that quadrant. But if you're not having a hard time drawing in the triangles, then just draw the triangle in, especially if you can tell what quadrant you're in. So what are we given? Sine is 1/2. Now remember, sine is opposite over hypotenuse. Well, don't we know this one's the square root of 3? Because that's that 2 and 1 and square root of 3 reference triangle we should really, really have down now. Okay, so we're in good shape. Wait a second, though. This one's got to be negative. Sines are going to kill you. Remember how I told you sines are going to crush you in Algebra 2? They're going to crush you. Got to be careful with them. God, I love coffee. All right, so cosecant. Let's see. Sine goes with cosecant theta. So if I want cosecant theta, it is just the reciprocal of sine. Oh, that's easy, 2 over 1. Cotangent is the reciprocal of tangent, and tangent is opposite over adjacent. So this is adjacent over opposite. Oh, I haven't labeled these things. Hypotenuse, opposite, adjacent. So adjacent, negative square root of 3, over opposite, which is 1. So this is just negative 2 square roots of 3. Over 1, but who needs the over 1? All right, moving on. So if theta is an angle in standard position, I'm thinking we meant standard position, and P.3 negative 4 is a point on the terminal side of theta. What is the value? That sounds really complicated. Plot the point, kids. Plot the point. 3 negative 4. 1, 2, 3. 1, 2, 3, negative 4. So it's down here somewhere. There it is, right triangle. Now this is a 3, 4. I don't care if it's negative or not. It's a 3, 4, 5 right triangle. And you better know these. Bam! Shabam-a-rinsky. All right, 3, 4, 5. All right. What? That's all they wanted? Opposite, hypotenuse, adjacent. They want the sine of theta? Oh, the sine of theta is negative 4/5. Shabam. There she is. That was easy. All right, let's get going. One more. If the terminal side of theta is in standard position, ooh, we got standard position this time. Good. Negative 7, negative 24. Negative 7, negative 24. That's a point way down here. Remember, you always have to create the triangle with reference to the x-axis. I cannot stress that enough. All right, so we've got negative 7 squared plus negative 24 squared equals x squared. Do you know what this one is yet? This is 49 plus 576 is equal to x squared. So x squared is equal to 625. So x is equal to 25. Let me just make sure. So 7. Ooh. So 7 squared plus 24 squared equals 625. And then if I raise that to the 0.5, remember 1/2 as an exponent is really a square root, I get 25. All right, so my hypotenuse is 25. Now let me label it. Hypotenuse is h. There's the adjacent side. I don't know why I put O. There's the and O. Remember, opposite the angle is the O. So secant, secant goes with cosine, and cosine caught another hippie. So this must be hypotenuse over adjacent. So the secant of theta is hypotenuse, which is 25, over adjacent, which is -7. Always leave negatives out up in the numerator. There it is. And she'll probably have, hopefully this, she has the negative. She just has the negative out front, and that's okay as well. All right, one left. Where the heck did it go? Determine the exact value of the 6 trigonometric functions. So we got to find all 6. Really, we're just going to find 2 and flip them, right? All right. So 2, -1. 2, -1 should be right about here. So 2, -1, and x. So x squared equals -1 squared plus 2 squared. Do you know that's just 1 plus 4, which is 5? So x squared equals 5. So this is just the square root of 5. Crap, you jerk nooms. Here's my hypotenuse. You'll see why in a minute. This is the opposite, and this is adjacent. So let's get those 6 trig functions written down. I'm going to pause this. You write those 6 trig functions down. Write them, the originals here, and the reciprocal functions here. Come on, get them down accurately. Start to learn which ones go with which. It's going to become important, especially when we do proofs with trig functions. Oh yeah, the P word. All right, did you get them down? Huh? You got them in the right places? All right, hopefully. Remember, S goes with C. C goes with S because we hate students. Some old hippie caught another hippie tripping on alligators. On whatever. So here we go. Sine is opposite. This is why you're going to see why I don't like Newman. Sine is opposite over hypotenuse. So -1 over the square root of 5. So hopefully by now you multiply by the square root of 5 over the square root of 5. You get negative square root of 5 over 5. Now the reciprocal of this is just negative square root of 5 over 1. Cosine is adjacent over hypotenuse. 2 over the square root of 5. And if I multiply by the square root of 5 over the square root of 5, I get 2 square roots of 5 over 5. Now the reciprocal of this one is the square root of 5 over 2. And finally, tangent's easy. Tangent would be -1/2, opposite over adjacent. And then tangent, cotangent is just the flip of that. -2 over 1, or just -2. And let's real quick make one more analysis here. All students take calculus. Cosine is the only thing that should be positive, cosine, and its reciprocal function. Positive, negative, and negative. Yes, we made it through day, whatever the heck this is. I think this is day 3, kids. All right, day 3 is over. Hit subscribe, hit like, and keep working hard. The year is almost over. It's downhill from now.